fact that they are more mathematical and more explaining like physics or natural sciences, that's because of evolution. It wasn't like that before. Because the new conception and new paradigm of how to do social sciences is to do statistics, is to quantify, you know, even if it's a trivial thesis. In sociology, sometimes you have to give, at the end of the thesis, to show that you did experiments, in which you did survey, statistical analysis, and so on, because otherwise the thesis might not be accepted. I know I was on the committee of someone who writes on post-colonial science education, and she had to put a chapter, at least at the beginning, before I was complaining about it, that seems too scientific, for the subject, too scientific in the sense that it's too quantitative and it's based on methodology that is not good for the studies that she does, because there are not enough, in order to do a good statistical inference, you need, a large data. You cannot do a good statistical inference on 10 people, for instance, or 30 people. You need 10,000. So, and you need certain kind of assumption about them. But you will see more and more in sociology or that you have to do it at the end. Otherwise it's not scientific. It's not quantified. You don't do statistics. It's not scientific. So this is part of revolution. It wasn't always like that. Sociology was much more connected to philosophy and to humanities. Before you look at it in the late 19th century. Not to look at Weber or some other people, those of you who study sociology, you see that it's much more philosophy. And remember, the methodologies are being changed with revolution and so on. And so Kuhn, in a sense, undermine certain view of the rationality of science. Science is privileged considered by the society, but it's not because, objectively speaking, and for all times, it has a better rationality. Because the notion of rationality changes. It's part of the propaganda, in a sense, of scientists. To brand themselves. And it's also what they believe. And what we all believe, because we were educated in a certain way. That certain type of rationality is superior to other type of rationality. Okay. And many times, as I said, future generation will consider us as not very rational, because they would have a different position. Okay. Any questions so far? So that's the first part of 2. Is the general picture starting to be clear? So Kuhn has a different way to describe the history of science. According to Kuhn, and it's according to his view that there are paradigms. So according to Kuhn, science starts with immature science, starts with pre-paradigm era, in which the scientific community works with works with different kinds of paradigms. So for instance, if you read the book, it talks about the development of electricity. At the beginning of electricity, there were different paradigms, competing paradigms. So there were different groups that had different ideas about what electricity was, each of which could explain something, but not everything. And so this is an era in which what the scientists do looks like science, but it's not science because there is no one ruling paradigm. It's pre-paradigmatic, it's pre-science in a sense. It may look like science, but it's not unified by a paradigm, and there is no one. The science starts when there is one group taking over with their paradigms and marginalizing the others. After that, there is normal science. Normal science is what we call science in general. Normal science is linear, it develops linearly. It's under a certain paradigm, and it doesn't challenge the paradigm, it just develops aspects of the paradigm. So normal science is what scientists do most of the time. It's like following the party line. It's not trying to have a revolution. If you are revolutionary, many people will not listen to you. So if you want, in a sense, it explained why people didn't listen to Ludwig Fleck. It was too early. It was very much against the paradigm. It was too early. They needed, to be, according to, if we use Kuhn ironically, like to say that you had to wait another 30 years, for people to be more receptive. That there would be some sense of crisis in describing the history of science. So there would be another crisis. We do not say that, but that's one way to look at it. So when there is, it's not that, for instance, there are not people don't think about alternative to the main science. Because science, even the most successful sciences, have always problems. So there are always people, every day there are people who try to develop new theories. Most of them you will never hear. And some of them, when there is a significant enough crisis, they will cause a revolution. So for instance, Newton's theory had a kind of crisis already maybe 30 or 40 years before Einstein actually came with the general relativity, or special theory of relativity. But it took time. It wasn't ready enough. People were not ready. That's one reason. And another reason is that we need a better, what people consider a better option, or something like that. So scientists, don't change alliances very easily. Partly because they were educated in a certain way, they believe in it. Another reason is that changing alliances is a dangerous thing. If you try to go against the mainstream, you may be penalized. You may not have a good career, you won't publish your papers, and so on. So normal science is the science that is more dogmatic in a sense. It works within a paradigm. It's more development within the paradigm. It's like puzzle solving. And then, at some point, there is a crisis. So, at some point, the puzzles start to be conceived as anomaly rather than, or counter-examples rather than just puzzles. It's not that they change. It's the same problem, but suddenly the scientists conceive this problem differently. Suddenly, they start to feel that there is a crisis. And then they're more open to change. And at some point, there is a revolution, and then there is a new normal science. Usually, the old scientist or the one that, the old supporter of the previous paradigm would not go to the new paradigm. They would just die at some point, or just retire. And the new ones, the young ones, we go, what works better, what is like more, and so on. And this cycle continues. So there's a new normal science after the revolution. It works, we don't know for how long. Newton's theory worked for 300 years, and then there was a revolution. And classical physics also was for a long time, and then there was the quantum revolution. And who knows what will be the next revolution? We cannot predict it. It's like political things. Nobody predicted that the world would come down in 1989, or nobody predicted the Arab Spring or something like that. It's not that there were a problem before. Problem were for a long time. But at some point there is a revolution. It's not easy to explain why at a certain time. Maybe because suddenly people are more prepared to observe. They feel more in the crisis, and there is an alternative, and they just change alliances. So let's see this in a little bit more detail. So we start with immature science, which look like science, but it's still people are struggling to have a kind of unified conception of the field. And at some point, one of the paradigms that are competing wins. And we have normal science. Normal science, has always a lot of problems. There are things that we cannot explain, but the scientists are not worried too much by that. They kind of say, well, let's leave it aside, deal with it later. It's just a puzzle, that we don't know yet how to solve, but we will solve it, and so on. But because normal science is relatively narrow-minded, because it has a paradigm, it cannot work, the solution that it can give is relatively limited. And at some point, there are more and more puzzles that the normal science cannot solve. And then there is crisis. Before, the inability to solve these puzzles are blamed on the scientists, that they are not ingenious enough, they have to be better or something like that. So there is the idea that there is a solution, but they don't know how to solve, or they have to improve a bit, but it's not a problem for the paradigm. When there is a crisis, the mentality changes. It's not that the scientists cannot solve, that there is a problem for the paradigm. There are more and more problems. So they start to call it anomaly rather than just puzzle. And the more and more anomaly, at some point, there is less and less belief in the paradigm. And when there is less and less belief, the scientists are ready to change alliances. So the idea is that it's not enough that there are like alternative. The scientists will not look at the alternative if they have strong belief in the paradigm. Their belief has to be weakened before they are willing to change alliances. Once the belief is weakened and they are willing to change alliances, and there are enough problems in the theory, enough anomalies, then there is a crisis, and there is a period of crisis that will end up with revolution. And revolution is a change of paradigm to a new paradigm that changes the metaphysical assumption, the methodology, the way we think about the science, the education, changing of the textbooks, and so on. Many times you will say, we just try to have a newer and more updated textbook, but it's actually changing. It's a new textbook according to the new paradigm. So there is a crisis, there is a revolution, an emergence of new science, normal science, and again, crisis, revolution, normal science, so it's continuous. Like there is this structure, and this structure works for any science. So that's according to Kuhn. It's not a linear evolution. Every time there is a revolution, it's not a linear evolution. Every time there is a revolution, it's a new paradigm. There is no continuity with. There is just the attempt to show that there is a continuity, but not real continuity. It's the education that causes us to believe that there is continuity. So let's look at the tri-paradigm era. There are no clear guidance for the investigation, no agreement on which phenomena to explain and how to explain it. No general conception of how to deal with the issues, and so on. So there is no clear vision. In pre-paradigmatic science, there is no clear vision. There are different views, there are debates, The debates may be very intelligent, but they are not rational in the sense that they don't have common ground. There is no neutral ground in which to debate which is better. So, the issue of paradigmatic science that it's not unified. And science is unified. So what happens when there is, when the pre-science develop into science is that now the activity of the scientist is unified under one paradigm. And that's the ruling paradigm. All the other are marginalized. They might still publish sometimes. There might be some people that work on other paradigms, but they will be marginalized. They usually would not publish in the main journals, they would not get the best jobs, and so on. So for instance, in quantum mechanics, there was always a paradigm by David Bohm, who was a physicist, the different paradigm, and now there's actually a lot of, at least philosophy of physics, or quantum mechanics think that it's better than the orthodox quantum mechanics, but he was marginalized. For many years, he stood that the people who followed his theory would not get a job in any place. Now there's some university that if you don't follow his theory, you won't get a job. So, I mean, for Kuhn, that's a normal thing. It's not that, like scientists and universities are open-minded. They have a certain, they portray themselves open-minded, critical, and all these things, but they follow certain paradigms. Paradigm was to do quantum mechanics in a certain way, much more along the positivist, philosophy. So other paradigms were just marginalized. It took about 50 years or more, and the development of the science was very different, could have been very different if his paradigm won. But he didn't. And that's what happened. So it's not that science developed linearly in a way that, you know, the cultural or other things, are just noise. They actually may change totally the development of science. So, at some point, the pre-paradigmatic science become a normal science. A normal science is the way that we were educated that science is always like. So that's, so Kuhn is only a phase, and that's the normal science. And in normal science, so it starts when one paradigm became like ruling, and the normal science scientists work under a certain paradigm. This paradigm controls, in a sense, all aspects of scientific activity, including the invention of new hypotheses and so on. Within the paradigm. The paradigm tells us what assumption to make, metaphysical, methodological, experimental. It tells us which problems are important, which are not. It tells us which puzzle to try to solve, which not. Typical activities of normal science is making more accurate existing theories, for instance. It's not replacing theory, it's just working on the current theories. Improving existing measurements procedure, and so on. Extending the scope of the theories of the paradigm, so we can explain new phenomena with these theories. Reconciling the paradigm with some data that seems not to agree, try to reconcile and so on. But it's all from the point of view of the paradigm. Removing existing anomaly and conceptual difficulties and so on. So it's all within the paradigm. No attempt to challenge the paradigm, to falsify and so on. So Kuhn talk about puzzle solving as paradigm to say that a puzzle is developed by someone. For puzzle there is a solution. Well, you won't work on puzzle in the newspaper if you didn't think that there is a solution. No? So the scientists work and believe that the paradigm will give a solution to the question that they ask and the problem that they try to address. And also, puzzle has certain rules. It's not that you can do whatever you like. So it's all determined by the paradigm. And they try to solve well-developed problems according to the paradigm and just leave aside things that the paradigm cannot deal with very well. And more to say that this is for the future. We believe that our paradigm will develop our theories, and we will be able to deal with it in the future, but for the time being it's fine to leave it aside, although it seems to contradict the face of this, our paradigm. And the idea is that in normal science, the failure to solve scientific puzzles is to blame on the scientists, not on the paradigm. So the scientists have to become better. They have to develop, continue to develop, so they can solve the problem. Some of the puzzles could be difficult, but there is the idea that you can solve them. There is a solution. It's actually very difficult to explain why the night sky is dark. There's a problem that you would think that, this kind of stupid question, but it was very, very difficult to explain. Okay, so Lakatos said that all theories, always have sea of anomalies. So he said it against Popper. He was the one who replaced Popper and belonged to school. Popper always Peter about it. He wrote Lakatos and then he tried to stop talking to him. But Lakatos said that against Popper that if Popper was right, no theory would have even take off the ground, would have any chance taking off the ground, not to mention fly for a while. Because there are always anomalies from the start. So scientists are not discouraged by the fact that there is an anomaly. They believe that the paradigm is promising. That's the issue. What makes scientists live with the paradigm and be part of the paradigm because they are educated to believe that it's promising. And if it's promising, they can live with anomalies. They just call them puzzles. It's a nicer word, no? Anomalies sounds like negative. Puzzles is kind of more interesting, more positive, and so on. And so they don't throw the theories because they are these puzzles.